Myself, Dr. B.R.Chavan. Today we will go for MCQs regarding the circular motion. We have previously quick review for the topic circular motion. Now we will go through the MCQs based on that topic. Different examples of the circular motion that should be considered by you for the different questions that may be asked on this basis, which are not involved in our course study. The MCQs that will be based upon the theoretical part, that will be quite easier for you, but your emphasis should be on the numericals so as to score maximum marks for this topic. So we'll start the MCQs for this topic. The first MCQ that we'll go through is the ratio of angular speeds of hour hand and minute hand of a clock is, and the options are option A 1:12, option B 1:6, option C 1:8, and option D 12:1. I will repeat the question. The ratio of angular speeds of hour hand and minute hand of a clock. So here, one thing that is known to us, the periodic time of the hands of the clock, and it is merely the ratio of the angular speeds. The angular speed, it will be given by 2 pi by t. So the ratio of hour hand, the periodic time for the hour hand, it is 12 hours. So it will be 12 into 60, and the same for minute hand, it will be omega 2, it will be 2 pi by 60. So likewise, we can have the ratio of those two, that will be omega 1 upon omega 2, it will be 2 pi upon 12 into 60 into 60 upon 2 pi. So that will be equal to 1 by 12. So the correct option, it will be option A, that is 1:12. So likewise, we can have the ratios if the hands of the clock are mentioned, that may be, the pair may be by changing the pair as minute hand, second hand, or hour hand, second hand. So the same question can be repeated likewise. So this is quite easier one. So we will go for the another one. the angular displacement of minute hand in 20 minutes. That is the next MCQ. The angular displacement of the minute hand in 20 minutes is, options are pi by 4 radians, option B pi by 6 radians, option C pi by 3 radians, and option D 2 pi by 3 radian. So here again it is related to the clock, and we know the periodic time of the clock. So the period of a minute hand, it will be 60 minutes. So here we can have a simple ratio. So how much displacement, angular displacement, it will perform in 20 minutes. So in 60 minutes it will be confining the angular displacement that will be equal to 1 revolution, that is 2 pi. So far in 20 minutes how much it will confine? So it will be 2 pi into 20 upon 60, that will be pi by 3. 2 pi by 3. So the correct option for this MCQ, it will be 2 pi by 3 radians. That will be the angular displacement of the minute hand of any clock in 20 minutes. So in this way we can solve this problem. So we will go for the next one. The angular speed of the minute hand of minute hand angular speed of the minute hand of a clock in degree per second. And the options are option A, that is 1, option B, it is 0.1, option C, it is 0.5, and option D, it is 1.5. So here also the similar trick can be used, that as we are knowing that the angular speed here it will be given by 2 pi by t, and we know the periodic time of the minute hand, and during one revolution, one rotation, it will be covering the distance that is 2 pi, means that is 180 plus 180, that is 360 degrees. So we can have omega, it is equal to 2 pi by t, and 2 into 180 upon periodic time, it will be 60 minutes, that is 60 into 60. So here the angular speed in degree per second, it will be equal to 0.1, means the option B, it is the correct one for this MCQ. Answer will be 0.1 degree per second. That will be the angular speed of the minute hand. So this has been expressed in the different units only, and it is easily calculated. We will go for the next MCQ, that is a car goes round a circular track. Car goes round a circular track of radius 50 meter. Of radius 50 meters, 50 meters, with the speed 25 meter per second. With the speed 25 meter per second, its angular speed is options are 0.5 radian per second, option B 2 radian per second, option C 5 radian per second, and option D 12.5 radian per second. So here the linear speed of the car which is moving along a circular track is provided to us. The radius of the circular track is also provided. R is equal to 50 meters, and the linear speed, it is 25 meter per second. So as we have to calculate the angular speed, and we know the relation between the linear velocity and the angular velocity, that is v is equal to r omega, or omega will be equal to v by r. So it will be 50 upon 25. So it will be 25 upon 50. That will be 1 by 2 or 0.5 radian per second. It will be the angular speed of the car. So the option A is the correct one. So in this way we can calculate the various numericals that are much easier, that will be based on the first few quantities that we have explained for the circular motion. The theoretical questions based on this part are quite easier, that may be better understood and can be solved easily by you. But we will go for few of them. The next one is related to the same. It is theoretical one. A car is traveling towards north. A car is traveling towards north. The direction of the traveling of the car is provided to us. The angular velocity of the wheels is due. The angular velocity of wheels is due. Options are A, east, B, west, C, north, and D, south. So here the motion of the wheels of the car is to be taken into the consideration. If this is north, suppose the car is heading in this direction, the wheels will be revolving in this direction. I will fold the fingers of my right hand in that direction with outstretched thumb, which will be indicating the direction of that angular velocity. So the angular velocity, it will be, this is north, this is south, so it will be the west direction, east and west direction. So it will be the west direction. So option B is the correct one. So it is easily understood that what may be the direction of this velocity, angular velocity of the wheels of the car that is heading towards a particular direction, or in this example it is heading towards the north direction. So we will have another example, another MCQ. A particle of mass is revolving. A particle of mass m is revolving in circle of radius r. Capital R here, and particle B of mass small m revolving along the circle of radius small r. Particle B of mass small m revolving in circle of radius small r. If they take same time to complete one revolution, if they take same time to complete one revolution. Then the ratio of their angular velocities is angular velocities options are A, capital R upon small r. Option B, it is small r upon capital R. Option C, it is 1, and option D, it is capital R upon small r square. So here two different particles are provided to us. One is having mass capital M and radius capital R, while the other particle B, it is having mass small m and radius small r. And the ratio of their angular velocities is to be compared. And here their periodic time is the same one that is provided to us. If T1 is the periodic time of the particle A and T2 is the periodic time of particle B, then T1 it will be equal to T2. As the periodic time of the particles that are confining the circular motion, it is similar one, then their angular velocities will be similar, that is omega 1 will be equal to omega 2 if omega 1 is the angular velocity for the first particle, that is particle A, and omega 2 is the angular velocity of the particle 2 or particle B. So these are the similar one, so their ratio it will be equal to 1. So the option C is the correct one and the answer is 1. 1:1 or 1, that will be the ratio. The numericals mostly that will be tricky. The hint to solve them it will be provided in themselves only, and mostly the calculations that has to be performed, they might be also tricky one, and you can calculate them orally, or you can have a very easy exercise for the calculations of those numericals that are provided within this. So we will go for another one. Two particles of masses capital M and small m. Respectively, and revolving in a circular orbit of radii capital R and small r. If the time period of the both particles is equal, then the ratio of their linear speed is and the options are option A, small r upon capital R, option B, capital R upon small r, option C, 1, and D, square root of capital R upon small r. So these are the options here, and again the similar trick has to be used for solving this one. The periodic times of both the particles is similar, that is T1 is equal to T2. So therefore we can relate their angular velocities, that is V1, that omega 1, that will be equal to omega 2, and as we know that omega, it will be equal to V by R, and omega 2, it will be equal to omega 2, it will be equal to V by R. So again V1 upon V2, here it will be equal to capital R upon small r. So the correct option for this, it will be the option B, that is capital R upon small r, that is the ratio of the two radii here. So in this way we can calculate this one. So it is a little bit different, but we know the relation between the different quantities that are related with the circular motion. So properly by using those relations, we can calculate the various numericals based on this. So the hint for the same, it is provided itself in that particular problem. So carefully we will have to first read that MCQ which is provided to you, and then only we will be able to calculate that what is to be calculated or what has been asked there. So the next question is, next MCQ is, the angular velocity of a geostationary satellite is. The angular velocity of geostationary satellite is, and the options are option A, pi by 12 radian per meter, radian per minute. Option B, pi by 360 radian per minute. Option C, pi by 720 radian per minute, and option D, it will be pi by 24 radian per minute. It is also per minute. Option C, pi by 720 radians per minute, and option D is pi by 24 radian per minute. So here we know that the geostationary or geosynchronous satellite, it is the satellite that is revolving around the earth, which appears stationary from the surface. So it is appearing such because its periodic time is 24 hours. It is completing its one rotation in 24 hours, and it is rotating around the earth in the same direction as that of the spin motion of the earth. So it appears stationary, so it is a geostationary satellite. It is called as the geostationary satellite. So here we know that the periodic time of the satellite is 24 hours. So it will be equal to 24 into 60. That will be the minutes. And we have to calculate the angular velocity. Angular velocity is equal to 2 pi by t. So it will be equal to 2 pi by 24 into 60. So it will be equal to pi by 720 radian per minute. Means the option C is the correct one. So based on this knowledge, so we have to assemble the knowledge, organize the knowledge. The geostationary satellite that we have previously studied in the 11th and also in the 12th we have studied it in the in gravitational topic. So we have to organize that knowledge that geostationary satellite, it is the satellite which appears stationary because its time period is the 24 hours, and that can be same can be used here. The hint can be used here. In this way the problem can be solved. So it is quite easier one. If we know, we can relay the information that we have known elsewhere that can be used while solving those problems. The angular velocity of the earth is omega 1. The angular velocity of earth is omega 1 and angular velocity of our hand of a clock is omega 2 and angular velocity of our hand of a clock is omega 2. So those two angular velocities are provided to us. Then options that are given to us, omega 2 is equal to omega 1 upon 2. Option B is omega 1 is equal to omega 2 upon 2. Option C, omega 2 is equal to omega 1 upon 16. And option D, omega 1 is equal to omega 2 upon 16. So again here it is comparison, it is the ratio of the two angular velocities. We know that the periodic time of both those means the earth and our hand, it is known to us. The periodic time of the earth is 24 hours, that T1 it will be equal to 24 hours, and that of periodic time of the our hand it will be 12 hours. It will be 12 hours. So we can compare those by, we know the angular velocity for the earth, it will be 2 pi by t1. So that will be equal to 2 pi by 24, and angular velocity of the other hand it will be equal to 2 pi by 12, and the both can be in this way compared, and we will find that those two, the relation between those two, it will be omega 2 it will be equal to omega 1 it will be equal to omega 2 upon 2. So the correct option that will be the B. That is correct one. So that is the correct answer. So we will move further. Another one. So in this way, the relations and the general information that can combining it together, it will be helpful for us to calculate or to solve the numericals and the MCQs. A body is moving in a circular path with constant speed. The body is moving in a circular path with constant speed. Has options are option A, a constant velocity, option B, constant momentum, option C, constant kinetic energy. And option D, it is constant acceleration. Here, it is again a tricky question. A body is moving in a circular path with a constant speed. Means, this is the example of the uniform circular motion. And in the uniform circular motion, the magnitude of the velocity, it is not changing, but the direction it is changing one. It is changing time to time. And so, as velocity is the vector quantity, it may not be constant. The direction of it is changing. In the similar way, we can say that the momentum, the acceleration, along with the velocity, all these three quantities are the vector quantity and the direction is changing, so they may not be constant. The only remaining will be the kinetic energy, so the kinetic energy is constant here. So it is tricky question, but keenly, if you read the different characters of the motion that we have studied, you will know what is the correct answer. So the correct answer is the kinetic energy is constant. So other quantities that are provided here, that all are the vector quantities, and as the direction changes, those quantities are changed. So we will go for next one. Which of the following has maximum angular velocity? Which of the following has maximum angular velocity? And the options are option A, hour hand, option B, minute hand, option Option C, second hand, and option D, geostationary satellite. So all these are the objects that are performing uniform circular motion, and we know that the periodic time of all those is a different one. Our hand is taking 12 hours to complete one rotation or one revolution. The minute hand, it takes 60 minutes to complete one rotation. The second hand, it is taking 60 seconds to complete one revolution, and geostationary satellite, it is having the maximum time period along these, that is the 24 hours. So as we know that angular velocity, it is omega, that will be equal to 2 pi by t. So the t here, among those all four examples of second hand, it will be the smallest one. So the angular velocity of the second hand, it will be the maximum one. So in this way, the correct option is the second hand. Thank you.